All right, welcome folks. We'll give everybody a minute or so to start to trickle in here. All right, well, don't want to hold people up today. I'd like to welcome everyone to Asphalt Institute's second training session for this new odor management tool. My name is Shyla Blackadder-Dwyer. I am the director of EHS for Tamco Building Products, and I had the privilege of participating in the Asphalt Institute's working group that helped develop this tool. Little background, the tool was born out of a recognition that odor issues were becoming increasingly important to our member companies, and that odor as an issue is challenging, it's complex, and it has some challenges to understand the nuances of odor issues. Consequently, the Institute engaged SCS to help develop this tool, and it will help both our member companies and the industry at large. A couple of quick housekeeping things for today. So first of all, the session is being recorded, and so there will be a link sent out at the end of this. Second, if you have any questions during the training session, please use the Q&A function that's at the top of your screen. Post any questions there. Myself and Jacqueline will be moderating those questions, and we'll get to those at the end. So quick introductions of our speakers today. So first, we have Mr. Paul Schaefer. So Paul is the Vice President and Project Director for SCS Engineers. He is also recognized as SCS's national expert for conducting odor assessments and ambient air monitoring programs. He's considered an expert in conducting air quality assessments on specific air toxic criteria pollutants, as well as odor and odoriferous compounds. Paul directly manages the operation of laboratory quality olfactometer, I don't think I said that right, that means ASTM and EN methods for odor assessment. In addition, he has developed a state-of-the-art measurement techniques for surrogate odor compounds specific to various odor sources. Paul has in-depth experience at interfacing with regulatory agencies regarding performance and monitoring systems, air sampling networks, and continuous process monitors, which are operated for his clientele. He has had direct working experience with several agencies, including CARB. So welcome, Paul. Our second speaker today is Miss Tia Jeter. She received her bachelor's degree in chemical engineering from the University of Kansas in 2001 and went on to receive a master's in science of environmental engineering in 2003. Tia is a registered professional engineer and project director for SCS Engineers. Prior to SCS, Tia worked for DuPont's Sabine River Works facility in Orange, Texas, as the environmental coordinator for their ethylene manufacturing unit. Tia has over 20 years experience in environmental compliance field, focusing predominantly on air compliance for the chemical industry, agriculture, and solid waste facilities. So we appreciate both Tia and Paul today and their time to provide us this training. Like I said, please use the Q&A function if you do have any questions. I'll turn it over to Paul and Tia. Thanks.
All right, thank you, Shyla. As Shyla said, we have developed this odor management tool. What you're seeing on the screen right now, this QR code, if you haven't seen the tool, you can take a picture of it and it'll take you to the Asphalt Institute website where the tool is located. So feel free to snap a photo of that and go take a look. Let's see if this can work. Okay. So Paul and I are here today. We're going to talk about odor measurement and assessment as part of the second webinar in this odor series. So webinar 1 of 3, this was in February. We did the first webinar. Just as kind of a recap, we kind of just touched base on some of the basics of odor. So what is odor, how you define it, the chemistry of some asphalt odors, some odor sources common to the asphalt industry, and also odor generation and transport. If you want to see that webinar, the QR code on this sheet right here will take you to YouTube where that webinar was recorded, and you can feel free to take a look at that. Webinar 2 of 3. So today, what we're going to cover, we'll go over some odor monitoring options, including some direct odor measurements and use of chemical surrogates. Talk about how to complete an odor assessment, including some sample collection methods and analytical options, and then discussion on 2 odor assessment projects. So real quick, just a recap of some of the kind of bigger terms from webinar 1 that may be useful in case you didn't participate in that webinar. So some facts about odor pollution. A large portion of complaints issued to regulatory agencies concerning air pollution involve an odor component to it. So odor is not necessarily recognized by EPA as a pollutant, but it is generally regulated at the state or local level. Typically, this is part of like a nuisance odor law. Rarely are there direct physiological impacts from odor, but it is not uncommon that if an odor is perceived as offensive, you could have a secondary impact that arises, such as nausea or headaches. Something else to think about, perception of odors can differ by populations. So if you have a community that has, say, maybe a feedlot in the vicinity, those community members probably get used to that feedlot, and it's not as noticeable, versus if you have a visitor to the community who's not familiar with it, that may be a stronger odor perception for those people. Odor can be difficult to quantify through analytical methods because there's no single odor molecule, which is this combination of effects kind of makes it difficult to isolate odor sources. So something we talked about in webinar 1 was how do you define odor when it is this kind of perception that a person experiences? So there are some parameters that people try to use to try to characterize odor. So the first being odor concentration or the odor detection threshold. So for a particular compound, this is the point at which a person would sense a smell or an odor from that compound. So typically the lower the odor detection threshold, the stronger that compound is as an odorous compound. So if you think like hydrogen sulfide, that's the typical raw sour egg smell. People are used to that. It has a very low odor detection threshold. You could smell that at very low concentrations. Intensity refers to the perceived strength of the odor. Another way to kind of characterize it. The character is a definition of like, what does it actually smell like? Does it smell like sweet? Does it smell fishy, like nutty? There are ways to describe an odor, and that is considered the odor character. And then the hedonic tone is the perceived pleasantness or unpleasantness of an odor. So those are kind of the characters we try to use to try to define what odor is. The primary factors that impact odor transport is the method of release of the odor from your facility, the meteorological conditions at the time of the release, and then the local topography and facility structures can impact how the odor will move. A little more detail on that method of release. These are the parameters that talk about like the odor emission rate of a particular source. So this is a function of the concentration of the source and the volumetric flow rate of the release. The release velocity, which that can impact the mixing and dilution of the odor in the ambient air, the orientation of the release, whether it be vertical or horizontal, the release height, and then release temperature. These all kind of impact how it will transport from a facility. So that was a real quick kind of overcap on what we touched on webinar 1. The next section is our odor monitoring options, and I'm going to hand that off to Paul to discuss.
Thank you so much, Tia. And thank you to the Asphalt Institute for this opportunity. I appreciate it very much. When you're starting a program or you need to understand what you want to achieve prior to establishing your monitoring program or your assessment. It's going to be very different whether your goals are regulatory compliance or odor diagnostic and mitigation, or whether or not you're evaluating an odor control equipment for its effectiveness, either through, for acceptance testing or just evaluating its relative effectiveness for removing odor in various different circumstances and testing maybe different engineering settings to optimize your equipment. Or are you, do you have a litigation or liability issue that you want to solve, or provide data to support your positions? The next slide. So methods to assess odor concentration. there's a few ways we can do it, either through odor analysis, and we'll go much greater detail on what that looks like later throughout this section, using odor panels, and that's where you collect a sample and send it to a lab for analysis, or field olfactometry measurements, i.e. using a nasal ranger or an SS100 type of field olfactometer. That's for direct measurement of dilution to threshold concentration of odor, just using the human nose. Or if there's other ways, you can measure specific compounds if you are trying to figure out what odorants, what compounds are driving your odor situation at your facility. Measurement of specific compounds may be necessary. There's all sorts of types, from volatile organic compounds, different types of ammonias, amines, sulfur compounds. Sulfur compounds tend to have very low odor detection thresholds. And then when you're doing this, once you have the measurements made, you need to understand what odorance is related to that specific compound. Like Tia said, hydrogen sulfide has a very low odor detection threshold specific to that compound, but some compounds could have multiple orders of magnitude higher odor detection thresholds and might not be a main odorant, even though they're a high percentage of the composition of your odor samples. So again, just more ways to gather measurements. For on-site odor measurement, field olfactometry is a great way of assessing. Nothing beats the human nose as far as the perception of odor. There's a thing called an electronic nose, and we'll talk a little bit more about that. There's certainly some limitations to the use of it. Real-time sensors, so the measurement of a compound that you know may be a significant odorant at your facility, real-time measurement of that as a surrogate for your odor concentration. You may want to collect samples, and this all depends on the end use of your data, right? The type of data gathering measurements you're going to be using. For sample collection, you can use flux chambers. Those help you determine the flux of an odor through a specific surface area and are great for area sources. Direct probes, direct measurement, collecting lung samplers or method 18 samples, which allow you to collect a sample without your sampling equipment coming in contact with the sample itself. Time average sampling, long-term time average sampling to get longer averaged measurements, it might be necessary to meet detection threshold limitations. So once you've collected the samples, then you send it for laboratory analysis. That could be either use of odor panels on the analysis, laboratory analysis for odor surrogates, using potentially EPA methods, OSHA or NIOSH methods, and then using analytics and empirical estimates relative to those concentrations to determine a specific or rank your compounds for potential odor strength. And then it's not only necessary to understand your odor concentration of those parameters, but how is this being released from your facility? You might need sonic anemometers and things for flow measurements through stacks, vertical wind sensors, and other MET systems to understand the meteorological conditions at the time you're collecting your samples, and potentially tracers and taggets to mimic a compound's release and transport from your facility. So just some examples of field sampling methods. The ones listed here are kind of screening type of methods for initial surveys. We have a Jerome sampler out there that is used for hydrogen sulfide sampling. It's capable of measurements down to 3 parts per billion level. So just at the odor detection threshold or below it for most people. Field olfactometry using a nasal ranger. It's a system for determining dilution to threshold ratios using the human nose to develop a empirical measurement to a human perception. Other ways of on-site sampling, potentially calorimetric tubes to get just an idea of a range of a concentration potentially coming through a stack. other types of handheld meters, a Jerome, potentially a total VOC or PID meter to determine total VOC concentrations. And then essentially where you're collecting samples, often you need to know what is the air velocity at the time, because it's a significant variable in regards to odor concentration. Here's just some visual things of things we just discussed. So sample collection methods using lung samplers. The top left, a flux chamber method. This is great for assessing actual odor emission rate from area sources. Just think like leachate ponds or ponds, potentially storage areas or storage facilities of bulk material. And then the bottom left is a field example of a lung sampler, ability to collect a sample by removing the air surrounding a sample bag. That creates a differential pressure and the bag fills without ever coming in contact with your sampling pump. Summa canister, it's a great method for collecting either time average samples with a critical orifice and flow controller, or you can collect grab samples with the Summa canister. It's considered a whole air sample because now you can collect that sample and do multiple types of analysis on it, either for volatile organic compounds and a long list of those, or potentially a list of sulfonated compounds. So multiple types of analytics can be performed off a single Summa canister, making it a really efficient way of collecting samples, either for grab samples for instantaneous concentrations or time average samples. It's just an example of a field deployment where lung samples are collected for subsequent analysis, either from stacks, process equipment, passive sources. When you're collecting these types of measurements, it's critical to also take velocity measurements or flow measurements so that you understand the volumetric flow of the specific source. Yeah. Here's some examples of some dynamic flux chamber methods. Like I said, from collecting from area sources, you could actually collect them from liquid sources, as well as, just ground surface area or bulk storage areas. Sweep gas is used to facilitate the ability to calculate a flux of odor, a flux of a compound, as a function of the surface area that the flux chamber is situated over. So on-site measurements using nasal ranger. So this is based on the same principle of dilutions to threshold ratio, based on dilutions of sample required for the sniffer to detect odors. Generally, there's a wheel on there and you have preset dilutions you can set it to. For the nasal ranger, I believe it's 2, 4, 7, 15, and then it increases from there. Essentially, the larger number that of dilution to threshold. So background odors are generally between 2 and 7 D over T on a nasal ranger, and then you can get higher ranges for that. 30, 45 ppb. That's a very high concentration for an ambient measurement using the nasal ranger. So on-site measurement. So just briefly talk about electronic e-noses. Essentially what these are, I don't like the term e-noses because it tends to make it a strong correlation between a set of metal oxide sensors or electrochemical sensors that measure specific chemicals and then draw a direct correlation to an odor concentration. However, in general, most of the cases, odors are so complex. There's there's mixture effects. There's all sorts of things that go on. And after 25 years on the market and multiple different tools being developed, e-noses are still not very well correlated with human noses in most instances. So this is just a quick example of a laboratory measurements using an odor panel. What happens here is you collect the sample in the field. The sample has to be delivered within 36 hours, and we'll discuss that a little bit more later section. Within 36 hours, and then it's analyzed at a lab. And so the way this is done is you have certified sniffers. So you have people who have gone through screening to make sure that they have in the average range of smelling. You don't want what we call super sniffers, or people who are not able to detect compounds like the regular population. So there's a screening method that goes in there. So what happens is there's multiple panelists on it. Known dilution of clean air is provided to the 3 ports, with one of the ports having a diluted amount of the sample air. So 2 ports have clean, and one has odorous air at a dilution ratio. Panelists have to identify which port is different, and say, okay, port 2 has the odor, and you repeat this at increasing dilutions of odor into the clean air until which a majority of the panelists correctly identify the odor from the specific nozzle. And essentially, the higher the odor detection threshold, or higher the dilution to threshold concentration or odor units per meter cubed provided by the lab, the smellier or the stinkier the sample is. So why is olfactometry important? It helps the industry identify and assess the relative concentration of odors associated with its operations. Again, it provides empirical data to describe a human perception. And using multiple odor panelists, it's incredible how well this normalizes and works to rank odor sources and identify the odor strength of a source. It may be used for compliance. ACM standards provide guidance for accurate and standardized odor assessment, so it's repeatable, and it could even be written into a regulatory requirement. ASTM E679-04 is a standard practice for determining odor and taste thresholds using a forced choice ascending concentration series method, and it's the method that most odor labs utilize. There's also a European method utilized by some labs. So we just discussed a little bit about the importance of olfactometry, what it can do for you. There are some significant challenges to olfactometry, especially using odor panels. The holding time. They have to be analyzed within 36 hours of sample collection to analysis. So with that, that means you have to have the odor lab generally reserved ahead of time prior to collecting samples. You can't have an odor event, collect a sample, send it to the lab, and expect them to be ready to analyze it. It has to be forecasted and reserved with the odor lab. Odor labs, you have to ship it. So if you collect a bunch of samples and FedEx decides to lose your samples in delivery, and they get delivered 24 hours late, your samples have all turned to a pumpkin. They do no longer meet the ASTM standard. So you might have collected a bunch of samples that no longer have value to you, at least according and don't meet method requirements. So that's one significant restriction. Sample throughput. Most labs can handle as up to 12 samples per day, and that's generally on the high side. You may need to collect 24, 36 samples to describe your project, and that may be a limitation you need to be absolutely aware of, or you need to spread your sample collection out over multiple days. Like I said, the odor panel needs to be reserved ahead of time. Currently, commercial labs have limited availability. Does your meteorology line up with the project goals on the reserved sampling days? It's when you're trying to forecast these things out, it may be difficult, and the day you reserved your odor panel for analysis, the day before you need to collect your samples, and the meteorology might not line up with project goals. So that is a significant consideration and limitation. Also, site operations. What's going on in the site? If there's a specific type of process that you want to analyze and look, you need to make sure that lines up with your availability of your odor lab.
All right. So now that Paul went through kind of how you collect a sample, I'm going to do just a quick overview on how to complete an odor assessment. So when you start to do an odor assessment, kind of what we suggest initially is kind of define your program goals and design features. So some of these are listed out here. So you want to ask yourself, what is the end use of this data? What is the point of it? Is this for a regulatory issue, or is this just a proactive site wanting to kind of get a sense of where you are today? So understanding what that is. Looking at the odor causing processes and ensuring collection of representative samples. So you don't want to take a sample that may be happening during a malfunction or an abnormal operation and basing your assessment on that, unless that's the case you're wanting to define. Understanding the air matrix or process stream composition you may encounter, and from that you may be able to select some target parameters you want to look at, and also be mindful of potential interferences that could occur because of those compounds being together. You also want to look at precision and accuracy goals, including detection limit requirements. So this may require maybe collection of a sample over a longer period to make sure you have sufficient collection so your detection limits are met. From all of this, you can kind of identify the methods that will fit based upon those parameters, and then kind of see how all this affects your budget and resources. You know, do you have enough budget to do the full scale of an assessment? And if not, where do you need to kind of pull back on your approach? And then also considering your stakeholder expectations and what they want out of your program. Something we also suggest is preparing a roadmap kind of at the beginning of this process, once you go through that kind of planning for your monitoring program. This will kind of serve as a document it'll document your program elements for all stakeholders involved. This is really valuable, especially if you have community involvement in an odor issue where they want to feel like they are part of the process. It just helps with that community involvement. We also do see this required, especially when these studies are done because of maybe regulatory compliance issue or litigation. Coming up with a monitoring plan is very beneficial. It'll kind of help set the expectations for your field program. So in these plans, you will kind of set out the purpose and objectives of your assessment, the data end use, sampling and analysis methods, and then your quality control procedures. So once you've kind of gone through that, planning, the next step is kind of how do we understand or kind of define the odors emitted from your facility. So this is just kind of a general list I'll run through, and then some of them we'll touch on a little bit more. So first thing, you kind of identify your potential sources. Once those are identified, then you need to determine the odor concentration of each source, as well as the character of that odor source. You also need those release parameters, your flux and flow. So the volume of your release, your volumetric flow rate, your stack parameters, temperature, release height, all that good stuff. And then from that, you kind of build an odor emissions profile. That information is used with some meteorology. So this might come if you're lucky enough and have your own met station on site, that's fantastic. We can use that data. If not, you can get meteorology from a local weather station. A lot of times these will be at airports close to facilities that we could find that data. And from that, we will use a dispersion model to estimate downwind odor impacts from your facility. And then that model can be used to kind of come up with mitigation strategies. So you can model different scenarios to see what kind of options you have to reduce odor. So to build your odor source profile, by source, the first thing you're going to do is define the odor concentration. That's that D over T. So this is typically where you're going to go out, you're going to collect a sample, send it off to an odor lab and get that olfactometry analysis done to get your odor concentration. The odor lab will also typically give you the character of the source. So they'll define the odor of whether it's fishy, salty, sweet. You'll get that as part of that lab analysis. That can be used to help determine maybe if you're having offsite odor issues, are what people are observing downwind consistent with what that character is defined at from the lab. You also need to measure the source's volume flow. So those release parameters need to be collected as part of building this odor source profile. Something else we want to look at is the operation of that source. Is this a source that runs 24 hours a day? Or is it an intermittent source? Like if you're unloading asphalt trucks, you're probably going to get a peak amount of odor for maybe 15 minutes or so when they're unloading that truck until the next truck comes through. So it may not be a continuous source, and we need to kind of understand how that works, as well as any other operational scenarios. You could have a facility that maybe changes the product line. So do odors change by product line you're making? Different operational scenarios. You need to catch all of those kind of potential scenarios so you model a full odor profile from your source. With that, we can model your source. So the model inputs that we use in a dispersion model are the odor profiles for each source. So you have your concentration and all your release parameters. Facility structures are added, surrounding topography, and then local meteorological data. All of that goes into a dispersion model. And the model will predict ground level odor impacts surrounding your facility. Typically, we do this with AirMod. AirMod is an EPA accepted dispersion model, which is frequently used for modeling of other criteria air pollutants for air permits purposes, but it also can do odor dispersion modeling. And with this AirMod model, you can model many different scenarios to kind of see how it impacts the expected downwind odor from your facility. Like I said, with the model, you model different scenarios, and from that you can develop a mitigation strategy. So some of these, the strategies we've seen that some facilities may make is just a change to facility operations. Time of day impacts can be useful, and the fact that odor impacts a lot of times occur, or downwind odor is stronger when you have a stable atmosphere. A lot of times that happens in the early morning hours due to changes in temperature and kind of nighttime to morning time. That's when it's very stable. There's low wind, low mixing. So you may have stronger odors occur in those morning hours. So an option is, can we maybe avoid doing odorous activities those times of day and wait to do them later on in the day when we have more potential for mixing and dilution of odors? So those are just easy kind of just operational changes. You can also look at changing the method in which the odors are emitted. So if you have a fugitive source, which has very low movement or transport, it may meander very slowly away from a source and be still a fairly strong source downwind, versus if you can collect that, route that to a stack and vent it high up in the air. That way you would improve the chance to mix and dilute that odor and reduce its impact downwind. Other ways that we've looked at to improve mixing would be increased stack heights or velocities. And then kind of the last hierarchy would be to add those odor controls. That would be probably the most expensive option. So we start from the easy facility changes and then look at odor control towards the end. All of these are scenarios you can put in a model and see what that looks like to help a facility identify what their, from a suite of options, which one works best for them. Some key understandings and mistakes, to think about when you're doing these odor assessments is planning is one. Plan ahead and understand your limitations and constraints of your study. Make sure we're keeping in mind those operational considerations. So operating schedules, loading and unloading times, seasonal variations, those are all things that need to be kind of defined and understood in your plan. Also understanding the potential for bias or interference. Bad data in can be with bad decisions out. So you want to make sure that the data you're looking at is appropriate and there isn't any potential for misinterpretation. And then also just data limitations. If there's variability in data, dependencies that aren't considered, method errors in your analytics, those are things that again can lead to that bad data. So you just to kind of think about that as you're going through your odor assessment and make sure they're not being, you're understanding all those kind of risks. So that was a very kind of quick discussion on how to do an odor assessment. This next section, we're just going to go over a couple case studies on odor assessments that we've done to kind of give you a flavor of what those have looked like. This first case study, this was actually some odor work we did for an asphalt shingle manufacturing facility. This was a proactive decision by this facility just to kind of gauge where their current state was and if there was any room for improvement on potential odor reduction at the facility. So we did build an odor profile for the plant. We started this from the kind of the desktop assessment of identifying all those potential sources. From that initial assessment, we decided these are the biggest bang for our buck. We're going to go ahead and collect samples from those sources. We're also, while we're on site, we did measurements for all those release parameters for those sources. So we did all the stack information. We did measurements of fugitive sources. That way we could take all that data, put it into a model the source or the plant, and then from that help them identify potential odor reduction options that they could pick from. This slide just kind of shows you an example of the odor source profile data that we got through this study. The left-hand side shows you the D over T, or the odor concentration. So this is what we got from the odor lab. Sample was collected from, say, a storage tank, sent to the lab. This is the D over T we got. The right-hand side shows you that odor concentration times the volumetric flow rate of that source. So it kind of shows you that in certain circumstances, you could have an odor source with a very high concentration, but if the volumetric flow rate is low, your odor flux, or the mass, if you were to try to convert it from a concentration to a mass of odor leaving your facility, is low, which is why it's important when you're trying to build your odor assessment, you look at both. It's not just concentration. You have to understand how it's released and at what volume it's released from your facility. For this project, we took all that data. As I said, we put it in a model. This is again done with AirMod. The left-hand picture shows you what we call the current state of the facility. If they were to do no mitigation or reductions, the right-hand picture shows you the improvement that could be made implementing some of those mitigation strategies that were identified. And it just kind of gave them an idea of the range of improvement that could be made. In general, the odor mitigation plan that was kind of developed as part of the testing on site, we were also looking to see if there was an odor surrogate we could use moving forward that we could just sample for one parameter in lieu of doing a full odor panel to kind of help avoid some of the issues with olfactory. With that, we did analysis for total sulfur in conjunction with collecting odor samples to see if there was a relationship. And that is that plot you see on this graph, was the relationship for this particular facility between sulfur and odor. From that, we felt that there was a decent enough correlation there that moving forward, if they were to do odor reduction projects, we could potentially look at just total sulfur instead of having to do a full odor panel to see if it had a potential for odor reduction. So that was another kind of bonus that we got out of this study, in addition to the mitigations that were selected. So in this case, the facility, increasing some stack heights can be a pretty slight initial capital, but it's not super expensive. That can make really good improvements to odor. And then they are also going to be potentially installing some odor control just to see what impact they get from that. This next case study is one that Paul worked on, so I will hand it back over to him.
Thank you, Tia. Appreciate it. So, City of Marina, what a complicated project. If you can, as you can see here, I call this the pea soup of odor projects. It was at one kind of location or area, there was composting facility that also integrated food waste into their compost. There's a leachate ponds right nearby. There's a wastewater treatment facility and everything that goes on there, from lagoons to clarifiers to other types of removal facilities. There's also an active landfill with an open face, construction and demolition debris processing area, gas to energy plant, and so all sorts of different sources in one area. So the way we structured this project is to try to bracket each of these sources and subsources with a collection of a sample, upwind and downwind, from a specific source or subsource. So if you move on to the next slides, we had samples that were collected on site, and we also had samples collected off site, and we had roving samples. One thing about this project, and I think it's important, is that this was because this project was so complicated, each of the sources believed that the other source was the cause of the downwind impacts, and there's a lot of finger pointing going in opposite directions. There were a lot of people involved, from the community, the city, the specific sources that were being assessed, and then SES, who conducted the measurements and performed the assessment. And we got feedback from each of these groups prior to moving through the project to make sure that our data that we attained met the project goals. So for the project plan, task 1 was the initial review of information. We wanted to review complaint data and meteorological data associated with that complaint data, seasonal wind variations with according to the meteorological analysis, report those findings, and then we updated the overall project plan based on the available information we had at the time. What that did was we determined that there were specific seasons and times a day that were conducive to odor impacts into the communities. So we decided to design our monitoring project surrounding those same types of meteorological conditions. We also found out that there's certain operational practices and things that take place at those facilities that were also conducive to odor complaints. So that informed our field sampling and analysis plan. So we added odor investigation plan, field investigation plan, and what data were we going to report and how we're going to report that to the various stakeholders. So in our MET complaint data review, there were 60 MET stations in the region, but we've determined that only 3 were viable due to either data quality, the averaging times attained by that meteorological system, a lack of historical data being stored, the temporal resolution of that data. Like I said, its averaging periods weren't conducive, and how what proximity they were to the city. In a highly topographic area, you need to have fairly close meteorological to better describe the situation at your location. Region 1 is one of the odor sources, the landfill, and we used they had an on-site meteorological station, which ended up being perfect for the study, and another nearby station that we used to confirm the region data was similar and representative. We've determined that easterly winds were prominent during the morning, but taper off in the afternoon. And those morning hours were what moved odors toward the city from east to west. The majority of complaints occurred during the winter months and during the morning and afternoon hours, with morning being the most prominent. Thus, we utilized those periods for collecting our field sampling. So field study, how do we do this? We set up a bunch of different types of lung sampling devices. So each of those blue containers is a lung sampler that we built. We also use sampling pumps, programmable sampling pumps, set to collect 2-hour time average concentrations. And we forecasted wind events that would be persistent and fairly uniform over that 2-hour measurement period. During morning hour periods and when winds were light and conducive for odor transport. So for the field study, we had 15 of the 16 sampling locations were situated either on the region facility or the M1W facility, region facility being the landfill, M1 facility being the wastewater treatment plant. The region facility also included the composting operations that were also run by a separate contractor. The remaining fixed sampling location was at a church at the kind of the first residential type of area in close proximity to the odor source region as winds transport from the facility to the community. We also, for each sampling event, we had 4 sampling events in total. We had 4 roving locations that were collected when our personnel detected odors downwind from the facility. So with that, this is just another picture of the lung samplers. We used 100-liter PTFE bags to collect large sample volumes so we could do multiple analysis if it was necessary. And this is an example screen from what was taking place during sample test event 1 of 4. It shows the wind speed and conditions during the duration of the sampling event. As you can see, winds were from essentially the east to northeast for the direction of the sampling. We put our samplers out. Each of the crosses on there are a sampling location with the goal of bracketing the subsources and sources at the facilities, and then also the 4 roving locations and 1 sampling location downwind. Next slide. So for event 2, very similar setup. The winds were a little bit lighter, and generally when they're lighter, you're going to have a little bit more variability. So again, winds were from the north to northeast, but a little bit more variable and light at that time. These are very conducive type of meteorological conditions for transport of odor. Very little mixing, less dilution, and just kind of um, a slow creep of odor from the facilities into the communities. So that's kind of the description of test event 2. And just so you know, we had 4 test events. The results of the 4 test events, the tests are on the bottom. The relative concentration of odor specific to the 16 different fixed monitoring locations. We also incorporated our roving monitoring locations into the analysis. And it generated some pretty quality data that we were able to glean some conclusions from. And the following will be those conclusions. So composting operations were by far the most significant and consistent source of the downwind odor impacts. And looking back, this was something that was one of our hypotheses because they started integrating food waste into their compost facility, and odor complaints increased following that process decision. The open face was identified as the second most consistent driver of odor impacts into the community, the open face of the landfill. And then in regards to the wastewater treatment plant, the sludge drying beds were identified as the greatest source of odor from that facility. So now that we have those conclusions, we were able to provide some recommendations to the specific sources and to the community and the city. One of the recommendations was to clean out the ponds and sumps, specifically the pond associated with the compost operation that took that runoff from that. Used aeration as a subsequent measure to reduce odor impacts from that. Understand how wind and met conditions affect odor. Identify the best and worst times to accept odorous loads or conduct activities that can cause odor. Adjust the timing of waste acceptance and disposal accordingly. Specifically, light winds from 0.5 to 5 miles per hour from the north to the northeast promote ideal conditions for odor transport on site. If you can do anything to reduce or not perform site activities that you know are odorous during those specific meteorological conditions, it will help reduce your impacts. So recommendations. So additional operational type of changes. So limit the time periods for stockpiling and processing odor materials, and especially for food waste. Conduct compost pile turning during times of day and or under weather conditions that will result in the least offsite odor impacts. That's, higher wind speeds and potentially not in the direction of the community. Use enhanced procedures for handling of odorous loads at the active phase. You don't need to go into the details of that. Moving. So some physical odor reduction methods, barriers or windbreaks. These are some things that are fairly low cost ways that any facility can do to reduce their odor impacts. Vegetative screening is a proven method for reducing odor impacts by increasing dilution as well as active scrubbing of certain pollutants. So we recommended providing vegetative screening downwind from the M1 facility, especially on that southern boundary as towards the community. And if possible, conduct very odorous activities such as handling and processing of food waste in controlled enclosures. In controlled enclosures, then you can affect better odor control in an enclosure rather than it's very difficult to handle fugitive emissions. All right. Some further potential recommendations that you could use: apply deodorants, reactants, or neutralizers from your facility. These can be applied via spraying or misting or atomizing at the site perimeter. Consider controls for on-site composting operations. For one, aerated stack piles are proven to reduce odors. Using a gore-type cover system and then pulling vacuum on that and having that run through an odor scrubber or odor reduction mechanism. Increasing aeration, especially as it relates to food waste within the composting operation. Institutional changes. So one thing they could do is develop and implement odor management and control plans. There were no plans written specific for odors at each of these facilities. So an odor impact minimization plan should be, we said it should be required for the compost operation, and it should be revisited in the light of the and findings of the study. There were lots of things that the compost facility could have been doing to reduce odor impacts. Develop and implement an odor complaint response protocol. This is important as it helps with community relations. It helps the facility understand the relationships between odor impacts and complaints, understand the relationships between meteorological conditions and complaints. Conduct odor patrols and consider the use of air monitoring sensors and analyzers for specific odorants at your downwind locations. So again, you have better data to inform your decision making. So what's next? We're going to have we have one more webinar of the 3 that we've done to date. So we just listened to 2. Webinar 1 was performed at an earlier date, and the QR code for that was provided earlier. Webinar 3 is going to cover odor control technologies, various different types, odor control plan development, what to do with community outreach and how that should be handled, and potentially some additional case studies. Thank you guys very much.
Paula and Tia, thank you so much. I can't figure out how to turn on my camera. You'd think I've never operated Teams before. All right. Well, thank you, Paula and Tia. I don't see any questions in the Q&A, but as I said, a link to this session will be sent out, and there was the QR code at the beginning of this presentation for the original training session. So if you're interested in that, if there are questions, you can respond to Asphalt Institute and follow up with questions, and we'll be happy to reach out to you. Jacqueline, was there anything else to add?
No, just everybody have a great afternoon and celebrate St. Patrick's Day, and wish you all the best.
Sounds great. Happy St. Patrick's Day, everybody.
Thank you.
Thank you very much. Thank you, everybody. Appreciate it.